Hi, my name is George Ibrahim, and this is my fourth weekly summary for Physics 131. What we did this week was on Monday, we talked about the project ideas for Project 1, and we also came up with a time for starting the controversial topic for Canvas. And we learned how to use multimeters, and we use a castle kit to better understand what series and parallel circuits are. On Wednesday, we finalized our groups and ideas for Project 1, and we used the Castle kits again for series and parallel circuits. Friday, we used Castle kit again, and we also did some Project 1 group work. And the total time in class this week was 5 hours and 15 minutes. The total time out of class for me was approximately 4 hours. For the programming neat resource, I thought that Jasper David's neat resource was the most interesting because it was using Excel to program. For the makerspace neat resource, I thought Nathan Page's neat resource was the most interesting because it was talking about how they used 3D printers to print guns. Also, series and parallel circuits learned that series have the same amperage, voltage, and resistance all the way through. And each bulb has the same resistance, voltage, and amperage. And for parallel circuits, we learned that the equation for resistance is over here to find the resistance for each one and the total resistance. And for voltage, it was the same throughout the whole circuit. And for amperage, it was the same for each light bulb as well, just like in on the first series or the series circuits. For Ohm's law, we found out that the equation is voltage equals amperage times resistance, and voltage is measured in volts, which the units for volts is V. For amperage, it's measured in amps, and the units for amps is A. And for resistance, the measurements for resistance is ohms, and the unit for ohms is omega, the Greek letter omega. For power, we found out that power equals the amperage times voltage, or amperage squared times resistance, or voltage squared over resistance, and the units for power is watts. And the most useful equation you could use for power is power equals the amperage squared times resistance. And below you can see that when you double the resistors, that you have to divide the amperage by 2 within the squared, and multiply the resistance by 2, and that makes P equal, or the power equal, amperage squared times resistance over 2. For the multimeter, we learned how to use them to measure volts and amps. For volts, we figured out that the red wire goes on the all the way right place, and the black wire goes on the COM, and just like how it is up on the picture. And to measure the volts efficiently for the bulbs and circuits that we did in the class, we had to turn the dial on 20 volts. And for amps, to measure amps, we had to move the red wire to 10A and keep the black wire on COM. And to correctly measure the amps, we had to turn the dial on 10A. For our project 1, my group was with Hansel Posada and Chad Ostrander. Our idea was making a homemade radio transmitter and a receiver to receive the radio waves from transmitters to listen to the music from the receiver. And connection to life, I thought that it was kind of interesting of how the the power was measured in electric bills per hour, so it was like kilowatts per hour. And now I know if bulbs are like the bulbs like the dark is sucked out of them too much, like where the filament is broken between the two copper wires in the bulbs. So when instead of using a bulb that's dead, I can know that like if the filament's intact, then it's still usable. But if not, I could buy another one. And that's it for my presentation.